Hey guys, Mr. Minis here. I've got a quick little video for me to go over the coordinate geometry test that you guys took the Friday before the spring break. I know it's been a little while since you guys took this, but I had to wait until the very last student finished this to post this video. Obviously, otherwise they would have the answers to all of the questions. I will be making a similar video just like this for the probability quiz that you guys took yesterday, and again, as soon as the very last student finishes that, I will release and post the video for that one as well. Class average on this coordinate geometry test, I believe, was an 85 or 86. So good job. Once again, I want to tell you guys how proud I am of what you're doing, what you've been able to do from home. Keep up the good work. Class average on the probability quiz yesterday was 86. So you guys are very consistent. So keep up the good work. You're doing fantastic. All right, let's jump in real quick. This is not going to be a long video. Okay, number one on the test, coordinate geometry test. What is the center of the circle? I'll go up here to the equation and I simply flip the signs. Flippy flip, flippy flip. So the center is 2 comma negative 4. Answer is D. So if you guys want to dig up your test again and follow along here as I go through each of these so you can see which ones you got wrong and why. Number two, what is the radius of the circle? That guy right there, remember that's r squared, so we have to take the square root of that. The square root of 8 is the square root of 8, but I can break that down, simplify my radical, break that down into the highest perfect square and the leftover non-perfect square. That breaks down into square root of 4, square root of 2, and the square root of 4 is 2, so that breaks down into 2 root 2, which is answer choice B. Number three, what is the vertex of this parabola? All right, so the vertex, remember this is, it is a times x minus h squared plus k. So this is my h value. Remember, I always have to flip that sign just like in circles. You got to flippy flip. So my vertex is going to be 1, and then the k value, leave that alone. So that's going to be positive 1 comma 5. So that was B as well. Number four, which of the following transformations are correct? Okay, so going back here looking at this, I see a negative out front, so I know I've got a reflection. And I'm always going to have a reflection across the line y equals whatever the k value or the y value of the vertex is. So I'm reflecting around the line, y equals 5. All right, I have a number here, so that is a stretch. Remember, it's only a shrink if it's a fraction, something less than 1. So I have a stretch of 7. Again, this is backwards. You would think it's left 1, but it's right 1, so that's right 1. And then I have a plus 5, so it's up 5. And then you can see, actually, none of those are correct. E was correct. Looking at these three here, the only one that has, these two have a reflect around y is 5, a stretch of 7. This one says right 1, but that says down 5, and this one says left 1, so none of those are correct. So E was the correct answer on number 4. Number 5, which of the following is the correct standard form of the circle? So this is where you had to complete the square twice. We're going to match up all of our x's and leave a plus blank. We're going to collect all of our y's, leave a plus blank. I got to move this 13 to the other side. So that becomes a negative 13, and then I have a plus blank and a plus blank. So I have a plus blank and a plus blank. X minus 2 plus 1, that whole special case perfect square trinomial factors as half of the b term. Half of negative 2 is negative 1, so it factors as x minus 1 squared. The y perfect square trinomial, half of the b term is half of 8 is 4, so that factors as y plus 4 squared. Combine your like terms over here and you get 4. So x minus 1 squared plus y plus 4 squared equals 4, and that was answer choice A. Okay, number 6. What is the center and radius of the circle from the equation below? Oh, excuse me. This is still referring to this one here. Okay, so when we get done, again, we're going to flippy flip, so that becomes positive 1, that becomes negative 4, and then that's r squared, so we have to take the square root of that, which is 2. So the center is 1, negative 4, and the radius equals 2. And that was answer choice D. Flippy flip, 1, negative 4, over the radius of 2. Okay, number 7, what is the vertex of the quadratic function? We are in standard form. We have to complete the square to put it in vertex form. So I'm going to have, now this is the one that's different because everything's happening on the right-hand side of the equation. So I have y equals, and then I have x squared minus 8x. I'm only completing the square on those first two terms, so I'll leave a plus blank. Then I have the 15, and then I have another blank. It may be plus blank, it may be minus blank. Okay, we have this, take half of b squared. Half of b squared is negative 4 squared is 16. So 16 goes in that blank. And so I have to offset that with a negative 16. All right. So this perfect square trinomial factors half of negative 8, so that's negative 4. So it simplifies to, it factors as y equals x minus 4 squared, combine my like terms, minus 1. That was answer choice B. Number 8, which of the following is correct? So you had to get that right to get this one right. Again, I have to flip that sign and leave that one alone. 4 comma negative 1, and I have a transformation of right 1 and down 1. Or excuse me, right 4 and down 1. So that was answer choice E. Number 9, they give us the center and radius, and we have to come up with the equation. So we just go backwards. Flippy flip, flippy flip. We're in circles land. So that's x minus 4 squared plus, remember it's a squared plus b squared equals c squared is basically what this equation, where this equation is derived from, Pythagorean theorem. So flip that sign, x minus 4 squared, flip that sign, plus y plus 3 squared. If the radius is 9, remember that guy in the equation is actually r squared. Okay, so 9 squared is 81. And if you'll notice, none of those are up there. X minus 4, x plus 3, that's right, but the wrong radius. That's right, but again, the wrong radius. So none of those are correct. So E was the correct answer. Number 10, this is the one where you had 2 endpoints of a circle. So if I were to try to draw a halfway decent circle, which that's not a very good circle, but anyway, so these are the endpoints of the diameter of a circle. What is the equation of the circle? So this is the one where you had to use both the distance formula or Pythagorean theorem to find the length of the radius, and then you had to use the midpoint formula to find the center. The midpoint, you just add the x's and divide by 2. Add the y's and divide by 2. 1 minus 5 divided by 2 is negative 2. 3 minus 5 divided by 2 is negative 1. So my midpoint, or my center, is negative 2, negative 1. Now, to find this length here, again, you could have used the distance formula between these two. I chose to actually draw it and use Pythagorean theorem. This has a length of 6. That has a length of 8. So when I do a squared plus b squared to find the hypotenuse of my right triangle, if you set that up correctly, you got c squared is 100, so c is 10, or the distance is 10, but I don't want the diameter. I need the radius. So I got to cut that guy in half. The radius of this circle is only 5. So now I have what I need. I have the center, I have the radius. I'm ready to plug it into my equation. Remember, I got to flip the signs. Every time I go from equation to center or center to equation, I flippy flip. Flip that plus 2, flip that plus 1, and that's the radius, but remember the equation is r squared, so I got to square that, 25. So C is the correct answer. Number 11, which is the correct equation for the parabola? Here's the vertex. It says it opens down. So if it opens down, upside down, that means I have a reflection. All right, so you can cross out D and E because they don't have a negative sign. I have a shrink of 1/3, so there's a 1/3 in front, so you can throw out A. And then if it's negative 4, if the vertex is negative 4 or 3, remember this is my H and this is my K. Remember, I got to flip that sign. So it's X plus 4 and I keep the K plus 3. So the correct answer was C on number 11. Okay, for this next one here, I've actually pulled this right off of the normal test that I give. So these two questions is asking to prove what kind of triangle this is, equilateral, scalene, isosceles, and then tell whether or not it's acute, obtuse, or right. So I'm just going to throw my work up here for the normal open response test that I normally give. So here you can see I've drawn out the triangle here. I chose to use Pythagorean theorem to find all 3 of these distances. Again, you could have used the distance formula. If you did the distance between A and B, 1 squared plus A squared equals C squared, the distance came out to be the square root of 65. If you did the distance of CB, 4 squared plus 5 squared, add those, take the square root, that distance came out to be the square root of 41. The distance between AC came out to be the square root of 34. So put little x's right here. So none of those match. So that means that is a scalene triangle. So going back to y'all's test, the correct answer was B, is scalene Batois the night before Christmas. It's a scalene because the 3 side lengths are square root of 34, square root of 31, 34, 41, and 65. A is not correct because they don't have the square root. Remember, you got to take the square root when you do Pythagorean theorem. All right, going back to my work here, is it obtuse, acute, or right triangle? You got to take these three guys and compare a squared plus b squared, compare it to c squared. How do I know which one c squared is? It's the biggest one, okay? So I'm going to put the square root of a, I'll call this a, the square root of a squared plus the square root of b squared equals the square root of 65 squared. A squared plus b squared, compare it to c squared. When you square those, they just cancel each other out. So I get 34 plus 41, and that comes out to be 75, which is greater than 65. So remember, you got a right triangle. If c squared is shorter, if it's smaller than a squared plus b squared, that's got to close the gap. So that's going to make that an acute triangle. So going back to your test, the correct answer was A. It's an acute triangle because a squared plus b squared is greater than c squared. C squared is smaller. Okay, so 13 was A. Number 14, prove that that point is or is not on the circle. That's super easy. All you have to do is take these points, the x and y, and plug it into your equation. So I'm substituting -6 for x. I'm substituting -3 for y. And if you work all that on the calculator, 153 does equal 153. They match. So yes, that point is on the circle because when you evaluate that point, the equation holds true. So 14 was A. Number 15, which of these is not true? The correct answer was D. And the reason why this is not true is because when they get down here, when I say if c squared is greater than a squared plus b squared, it's acute. That's wrong. That should be obtuse. Okay, again, if c squared, got your right triangle, if c squared, if that hypotenuse is bigger, then it's got to open up for that longer hypotenuse. That's going to make that an obtuse triangle. So D was incorrect. That's not true. All right, and here we get to our transformations. 16, it says use the mapping here to figure out what's going to happen to this quadrilateral. Basically, this mapping, all it's saying is we're going to take all of our x's and we're going to subtract 6. So wherever the x is, I'm going to move it left 6. I'm going to take all of my y's and then I'm going to move it left 6. I'm going to shift them up 2. So literally all you have to do is take every x value and subtract 6, take every y value and add 2, and the correct answer came out to be C. When I take 0 and subtract 6, I get -6. When I take -3 and add 2, I get -1, so forth and so on. So we are translating left 6, we're subtracting 6, and we're shifting up 2. Okay, home stretch here. Okay, 17. We are going to reflect this around the x-axis. Again, you could have drawn this and you could have flipped it over the x-axis. You could have just counted, but again, if you remember the formula, if you had your notes there by your side, if you reflect across the x, it simply means you change the sign of the y values. So all these y's become, you switch them. So that becomes a +3, 0 is just 0, that becomes a +1, and that becomes a +5. So the correct answer, you leave all your y's, you leave all your x's alone and change the sign of all the y's. So that was E. Number 18 was our rotation. We're rotating 90 degrees about the origin. If you plot these 3 points, we have a triangle that's in the 3rd quadrant. Again, 90 degrees, that's clockwise, like you're turning a doorknob, because our quadrants are labeled in counterclockwise fashion. So if I turn this one click to the left, one quadrant to the left, I'm going to go from quadrant 3 to quadrant 4. And every time you do a 90 or 270 degree rotation, what do you do with these guys? You switch these numbers. So that becomes -2, -4. That becomes -1, -3. That becomes -4, -3. And then you got to figure out which quadrant you're in, and that tells you what the signs need to be. If I switch to quadrant 4, everything in quadrant 4 is positive, and the x is positive and the y is negative. So all of my x's are positive, and all of my y's are negative. Okay, so the correct answer should have been 2, -4, 1, -3, and 4, -3. And as you see, none of those answers are correct. I don't have a 2, -4 anywhere up here. So E was the correct answer. Number 19, what kind of function is that? We are dividing by 3 every time, which is basically Same thing, when you think about exponential, you think of multiples. I'm actually multiplying by 1/3 every time, or I'm dividing by 3. It's the same thing. So when you have a common multiple, that's exponential. Number 20, what's the equation of this? What's the equation of this function using the values in the tables? So first of all, you got to figure out what kind of function is it. So if I look at my first differences, I'm going down 5, down 2, down 1, plus 1, plus 3, plus 5. So the first differences are not the same, so it's not linear. But if I look at the differences of the differences, going from -5 to -3, that's plus 2, plus 2, plus 2. So all of these second differences are the same, so that means we are in quadratic land. Okay, so once I know that I'm in quadratic land, again, on the test review video, I showed you how to do it by hand. On the answer key, I think I showed you how to do it by hand, but I think in the lesson video, I showed you how to use your calculator. So just refresh your memory on that. If you go to press the stat button right here, stat, we want to edit our list. We want our calculator to focus. Press edit. You can see I've already got these numbers programmed into my calculator. So I've got the X's over here, I've got the Y's over here. And then you just press stat and you go to calculate. We know it's a quadratic, so we click on quadratic regression, press enter, and then it gives us our values. So the A is 1, so it's x squared. The B is -8, so it's x squared minus 8x, and the C is plus 18, so the answer to 20 was B. Alright, that's it. Again, I'll make another video for the probability quiz review and let you guys know when that is posted. Have a great weekend.